Welcome to episode 163 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes that object so interesting to astronomers. And now I will turn on the random number generator. This episode's coordinates are 10 hours, 22 minutes, 58.0 seconds right ascension, and plus 10 degrees, 1 minute, 53 seconds declination. These coordinates point to PSR J1022+1001. This object is a pulsar, as indicated by the letters PSR in the object's name. The letter J and the digits in the object's name give its coordinates. The pulsar sits in the constellation Leo at a distance of about 2,770 light years or 850 parsecs from Earth, which is kind of close, but not really close, at least in terms of pulsars. What makes this pulsar interesting is that it is a millisecond pulsar. This class of pulsars rotates really fast. Well, most pulsars rotate very quickly already, so I guess you could say that any pulsar rotates really fast, but PSR J1022+1001 is rotating even faster than many other pulsars. As a brief review, which will be helpful for understanding what makes PSR J1022+1001 special, a pulsar is a rotating version of a neutron star, which is the really compressed ball of matter left over from when a star multiple times the size of the Sun explodes as a supernova. The gravitational forces in these stars will compress all of the electrons and protons in the core's atoms into neutrons, so the core could be described as a single giant ball of neutrons. Pulsars and other neutron stars are typically 10 to 20 kilometers in diameter and have masses between 1 and 3 times the mass of the Sun. Because of the conservation of angular momentum, when a very large star with a little bit of rotation then dies, the compressed leftover core will end up rotating really fast. Most typical pulsars rotate once every second, which is already really impressive for something that is 10 to 20 kilometers across that weighs a couple times the mass of the Sun. However, PSR J1022+1001 rotates once every 16.5 milliseconds, or alternately 60.6 times every second. This is so insanely rapid that it does not fit into the scenario where the pulsar just retains the angular momentum of the star that it formed out of. Instead, the current theory is that millisecond pulsars like PSR J1022+1001 must have been in binary star systems at some point and must have gravitationally stripped away the gas from the outer layers of the companion stars that they were orbiting. This could have happened when, for example, the cores of the companion stars filled up with helium and the stars expanded to become red giants. The gas falling into the pulsars would have given the pulsars a push in terms of rotation, and they would have sped up to ludicrous rotational speeds, at which point I recommend watching Spaceballs to understand how extreme ludicrous speeds are. Anyway, PSR J1022+1001 has been found to be in the binary star system with a white dwarf with a mass of around 0.9 times the mass of the Sun that is in all certainty the leftover core from the red giant star that sped up the pulsar. Pulsars do eventually slow down by, in a strange way, radiating their rotational energy in the form of electromagnetic radiation, but they can keep spinning for thousands of years. Even accounting for this slight deceleration, millisecond pulsars in particular produce very steady pulses of radio wave emission. Notably, PSR J1022+1001 is one of 25 pulsars that have been used by the European Pulsar Timing Array to search for gravitational waves. These waves, which would be created by things like when black holes merge together, are effectively slight distortions in space itself, and they would cause slight variations in the timing of the observed radio pulses from PSR J1022+1001 and other millisecond pulsars. The group has already detected gravitational waves, but it should be interesting to see what comes out of these gravitational wave searches in the future. The location on the Earth's surface corresponding to the position of PSR J1022+1001 in the sky is about 150 kilometers southeast of Kapinga-Morangi in the Pacific Ocean. Kapinga-Morangi is actually part of the Federated States of Micronesia, but most of the other islands in this nation are a few hundred kilometers further to the north. Kapinga-Morangi just seems to be sitting by itself. Culturally, the island is more Polynesian than Micronesian. However, the people still probably feel more of a connection to the Federated States of Micronesia than the pulsar PSR J1022+1001. The website for this podcast is www.randomastronomicalobject.com, which you can visit to read information about the astronomical objects, view images of those astronomical objects, look up additional reference information, and send me random feedback. Also, just to remind people, you can also find this podcast and send me feedback on Facebook, Instagram, Threads, and Blue Sky. And I in fact had a little bit of feedback through Blue Sky. TK Arispe wrote, "Thank you so much for doing these. The nice thing about the premise of this podcast is that you won't run out of coordinates anytime soon. GRAO has become one of my podcast staples." Well, first, thank you for sending that in, and second, part of the reason why I did choose this format is indeed because it's a bit hard to run out of things to talk about in the sky. If I just did something like the constellations or the Messier catalog, for example, I would have finished up my podcast a couple of years ago. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy, and the sound effects are from the Freesounds project at www.freesounds.org. Thanks for listening.